Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed at building large-scale distributed systems.
Welcome once again to another episode of the Distributed Data Show. I'm Jeff Carpenter, live in the studio with Patrick McFadden.
How you doing, Jeff?
I'm awesome today.
Yeah?
Yes.
So you got anything new for me?
Well, I would like to talk about Spark today.
Spark? That's what's old is new again.
That's right.
Yeah, and we have a special guest, don't we?
We do. Joining us remotely is from New Orleans, Louisiana. NOLA is Mr. Russ Spitzer. Welcome, Russ.
Hey, Russ.
Howdy.
I think it's important that we highlight Russ as more than just a DataStax employee, more than just a developer, a badass developer on DSE Analytics. You're kind of a rock star in the Spark community, I have to say. When you give a talk on Spark, the room is always full because you seem to know a few things. Did you know that?
You know, it's one of the things I try to know, but I definitely think I'm as much a beginner as most folks. You know, it's definitely a process of trying to learn new things every day. You know, There's no magic.
There is no magic.
You know, let's save our imposter syndrome for another episode.
Exactly.
Shall we?
But I mean, to be fair, the Spark project is not static. It is moving constantly. Like any good project, any popular project, it's constantly evolving, constantly moving. And that's probably why we need to talk today. Because if you haven't been paying attention to Spark for a while, there's some things have changed, right?
Yeah, I mean, the project's changed a lot since the 1.0 era. I mean, a lot of people might think about Spark and they're thinking about RDDs and thinking about, oh, I've got to learn Scala, I've got to, figure out how to do these mapping and flat mapping, all these, functional concepts.
Well, catch us up, man. We probably need to be caught up because I know when 2.0 hit, I was like, oh, they changed everything. Help me. And I was an RDD guy or RDD. I keep saying RDDs because back in the day, no, because RDDs were what you did for graphing when you had like cacti. Remember the graphing product and his RDDs behind the scene that did. Never mind.
Right.
You have to be an old ops guy to get into that. Anyway, RDDs. So they changed everything. So maybe you can give us a catch up here.
Yeah. So, I mean, just to say, if you knew Spark before, you're probably learning about RDDs, these resilient distributed data sets, and you basically could treat them like a giant Scala collection. So you just have this giant collection and you did maps and flat maps and filters and all that kind of fun stuff. And then Spark would do a whole lot of distributed work for you. But what 2.0 really emphasizes and starts really focusing on is a different concept called datasets. And datasets, you might have heard of them as data frames, they're kind of interchangeable. A dataset is, or a data frame is just a data set of a specific type of thing. But it's basically a new way of talking about things. You don't have to know as much Scala. There's a lot of ways to interact with it that don't require knowing any programming at all. You can actually interact with it through SQL. And the cool thing about it is, unlike that RDD approach that we used to be using, this is a whole bunch of really common commands. You've got your group bys and your aggregates and your filters, and basically everything you could have done in SQL, you start being able to do with a set of common commands with Spark. So the real reason that this is all important is that data sets and data frames, when you do operations on them, you're not actually programming the low-level operation. You're not actually saying, this is what happens when a tuple comes in. The tuple comes in, we do something to it, and something goes out. That's what you have to do in RDDs. In Catalyst, you don't do that, or in data frames, data sets. When you do something in data sets or data frames, what it does is it takes the description of what you want to do, and it figures out under the hood how it should actually be doing it.
So
and it does that.
You mentioned Catalyst.
Yeah, I wanted to cap on that too. You just blew that right by, but Catalyst, you're like, oh, and because of Catalyst. No, you can't do that here. You have to explain yourself, sir.
So Catalyst is basically going to take the instructions that we give Spark. It's going to take those instructions and it's going to break them down into components that it knows how to reorganize and to optimize for you. So before, you were doing like RDD, I've got an object in, I want to get a member of that, I'm going to do get something. I'm writing a bunch of Java code or a lot of Scala code that's like dealing with these objects. In Catalyst, you say like, well, there'll be a row, and this row is going to have some elements, and I'm going to do something on this element of the row. But what Catalyst does is it looks at that and says, oh, you're manipulating this row, you're filtering on this column. I don't actually need to do that right now. I can tell that this operation can actually happen either earlier in the pipeline or later in the pipeline, and I can move it around. It says that we don't have to do things the moment you said to in the API. It says we can start reorganizing things to be more efficient.
So, all right. So I think back in the day, we were familiar with DAGs, directed acyclic graph, because that just rolls right off the tongue. But is Catalyst a replacement for that, or in adjunct to that? DAGs were about getting from point A to point B without doing endless loops. Of course, that's bad. But where is Catalyst? You mentioned the order of things. DAG did that.
So the Catalyst is actually building that DAG for you. It's just building an optimized DAG. So there's basically a new intermediate layer in between your query and what actually happens. So before, what you wrote is what happened. Now, what you write gets turned into what they call a logical plan, which is a description of actions that need to be done on the data. The data has to be filtered, the data needs to be joined, the data has this UDF that's applied to it. And then below that, it changes that into, well, if I'm Spark and I'm smart, I know how to do things, can I reorder this so that maybe the parts that take the least amount of data happen first rather than later? So, maybe doing a join after I do a filter is a really good idea because it's better to join less data than it is to join lots of data. So it'll reorganize things.
Okay, hold on. You're getting close to, you're probably thinking this too, cost-based optimizer.
This is actually one of the newest additions that has been added in 2.2 is a cost-based optimizer has been added. So one of the, I guess this is one of the newest kind of developments that's happening in Spark right now, is that we have all these tools now, these frameworks for taking user queries and doing optimization, just like if I was in a relational DB. But one of the problems with big data is we often don't have the statistics that you would need to actually make smart cost optimizations, right? We don't really know the cardinality of columns. We don't know, exactly how big a data set is. I mean, we're getting things off of a stream, we're reading from a file that doesn't have statistics on this sort of thing. So one of the big pushes, or in the last 2.2, was to first get in the first set of join cost-based optimizations. Well, they'll look at your different joins and try to reorder your joins to do the most efficient set of joins possible. I mean, this is familiar to anyone who's done a lot of matrix multiplication sort of stuff. There's an order.
Oh, I do it all the time. You, Jeff?
Oh, on a napkin especially.
Yeah, we do a lot of matrix math here on the show. That'll be the next show. Yeah.
It's my
Matrix.
Sudoku.
Yeah, well, Matrix Revolution was one of our best episodes. We're probably not going to release it. Sorry.
But, well, basically, there are different ways to get an identical result, and there are different ways can be more efficient. So there's, you use the cost-based optimization to try to decide which join should go first, which goes second, which goes third. I mean, even before this, there were all kinds of things like, well, I have a filter. I have this filter on this column. Why don't I see if the underlying data source, like if you're connecting to Cassandra, right, can handle that filter before the data ever gets to Spark? And it will move it. So even if you said the very last thing you're going to do is filter this clustering column, you have this huge query, and way at the end, you're filtering on a clustering column. It's going to be like, wait a minute. Let me just kind of push that back through the tree and check whether or not the source can handle that. Because if I can do that at the source before we even get into Spark, that's a huge benefit. And it can do that automatically for you.
Wow. So you've got me sold here on the upgrade. But what do you say to somebody that has an existing application that's built on previous versions of Spark? So do they want to rewrite all that Scala code that they have that manipulates RDDs, or what's the advice there?
Well, my main advice, I'm a pretty conservative programmer. When I think something is working and is stable, I keep it that way unless we have considerable reason to change it for business interest or otherwise. It is really nice to be in this new paradigm because inside of Catalyst, every upgrade that happens to this optimization engine is passed on to you. You don't have to actually keep updating your code to keep up with like, oh, there's an optimization here. It just will automatically be applied as you go through the versions. That said, if you've got your old program and it's running RDDs, all you have to do is recompile against the new binaries, and with a very few exceptions, it will still work on Spark 2.0.
So how heavy is this breaking change then? So is it really a breaking change, or is it just a massive change that is covered or masked to the end user?
So it's definitely a binary incompatible change. Mm-hmm. That we need to clear manually. You cannot just use your old compiled jars against the new Spark. It won't work. There are breaking changes in some of the exposed APIs. In 1.6, they started like introducing this idea of data frames and data sets and all of this. And those are completely incompatible with the APIs that are presented in 2.0. So you have to be aware, if you were testing out this feature in the 1. Line and now you're in 2.0, you'll hit a few compile errors and you might have to change a few things around. Things are in different places. But that said, a lot of the things are pretty much the same. So there are a few things. I guess some of the key breaking changes are the way that you are supposed to make a new context, the way you're supposed to initialize your communication with the cluster, and the way that you're supposed to handle sessions within this. So this whole idea of an optimizer comes along with its own idea of a catalog and its own idea of temporary tables and temporary UDFs and all this kind of stuff. And that gets locked into a new concept that's called the Spark session. So you might remember in Spark 1, if you were using Spark 1, something called the SQL context.
Yeah. That's gone, huh? Just when I got used to it.
It's still there, but it's kind of hidden now. It's basically, you access it and it's a wrapper around the Spark session concept. The Spark session is their new entry point for all of this great data frame data set goodness.
Well, I'll tell you, the SQL context was, when I found that, it was like the light shone, because that means I don't have to write Scala. And so I just dropped my massive SQL statement in this SQL context and I felt happy. So don't make it go away.
So it's there. It's just now this should tell you something about the direction of the project. The item you get now when you start up the Spark shell, the REPL that you get to just pop in and write Spark code with, gives you an object called Spark. And the object called Spark is a Spark session, right? So this is the target. This is the future. The Spark session has references to a context. It has references to this SQL context as well. But Spark is the main entry point. It's what they want everyone to kind of be going through. So
if we're de-emphasizing the need for Scala code, so is SQL is not the dominant, what is the dominant way that I interact? It is with the data frame API, or help me out here.
That's a great question, because this is the best part about the whole Catalyst scheme.
Good question.
Is that
great question then.
If you write your code in Scala, you write your code in Java, you write your code in Python, you write your code in R, they all go into that same machinery. So you can end up writing the same kind of query in any API you are most comfortable with, and you get the same performance benefits as if you had written it natively, because you aren't actually writing, again, the physical operations that are happening. You don't write that. You just write a description of how the data is manipulated. And because of that, Spark doesn't care what language you wrote that in. You basically just wrote a description. And it's like, well, I'll rewrite that description into the lowest level I can. And that actually goes into a really interesting other part of Catalyst. I don't know if you want to talk about that right now.
Of course I do.
No, you go. Put on the scuba gear. Dive.
This is one of the reasons that a lot of Python people are super excited about data frames.
I was thinking about that, because now they don't have to get the side eye from the Scala people, right?
Yeah. They get the same performance. You get the same performance if you write in Python, you write it in Scala.
Oh, we could stop the interview right now. That just feels so good inside. Because, Scala people, they do have that, right?
I know,
they're awesome.
They're really great.
But, they're like, oh, we're superior, though. Just a reminder, we are superior. And poor Python people have always been like, but it's easy, right? No, this is great. What an equalizer. What a great day for data.
Yeah. You could be an R user right now. You can write your R code.
Even better.
You get the same performance as the Scala. So this is really great. And the reason that all this works is that when it gets down to that physical layer, when it's actually writing the code that's going to perform your calculations, it's going to do two really awesome things. So the first is that it's going to change it into its own memory format, right? So you're going to give it like a row, and it's going to say, well, that row in Spark's view is just this series of bytes with these offsets, and it knows exactly where those offsets are. So it ends up writing these giant blocks of just binary data. No Java overhead, no objects, nothing like that. It's just a huge hunk of memory. So that's the awesome thing one. The second thing, since it knows this layout, it then writes custom Java code to do bitwise operations and that sort of stuff on the literal byte arrays, as they're coming through the system. So there is no Java serialization at all when you're working with data within this API. So
that's
it is
fantastic.
Yeah, that is really huge, because we know SERDI operations are the absolute slowest thing you can possibly do in Java. And they've never ever fixed it. Who's they? Oracle?
Who is they?
We blame Oracle for everything. So yeah, we should just blame them. SERDI sucks because of Oracle. I said it here.
I mean, you just got to think about the amount of optimizations that this brings into play, right? So instead of having an object that you have to call a getter on, and the getter has to be looked up, and then we have to figure out where would this be in memory, and it's got to be put onto the heap into a brand new Java object that's nice and safe to deal with. It's just going to go straight to the memory. And it says, well, I'm supposed to compare field X with field Y. So I just take those bytes and I can actually just do a native comparison.
That is really interesting. So this sounds a lot like most of this is memory mapped at this point. Is that what it is? Yeah.
So we're getting to this awesome layer where it basically is just operating purely on memory. Right. It's not giant Java objects that are going around anymore.
That save the heap. That will help a lot. Yeah, because I know that back when I was doing a lot of Spark work, just trying to manage all the different heaps, because every time the executor fires up, you get all the different workers going at it, and there's a lot of heap. It's like managing a herd of cats.
Yeah, I mean, you're doing a lot of garbage collection with tons of tiny objects that are constantly being made and destroyed, and all of this, just doesn't have to happen anymore, because inside of this paradigm, it's a block of memory, and out of it comes another block of memory. So that's it. So it's pretty great. So that's the awesome thing. If you're looking for more information on that, this is the in-memory format is called Tungsten. At least it was called Tungsten. I don't know if people talk about it by that code name anymore, but it's basically the in-memory format that happens after you do stuff. And another cool thing about that is that since it's got this direct memory format, you can start doing vectorized readers for a bunch of other formats that have set memory layouts. So if you know that your incoming memory looks like column A, column B, column C, column A, column B, column C, and you know where those offsets are, it can actually just grab chunks and move them directly over like 10 rows at a time and stuff like that. You can do all kinds of really cool things. Basically,
you're getting into like SIMD type operations that now optimize all these modern processors pretty well.
Yeah, I mean, it's basically, and the best part of all this, again, is that us, the users, we don't have to care about it. We don't have to think about it at all. All of this happens for us. You're using Python, this is happening for you. You're using Scala, this is happening for you. You're writing SQL via JDBC client, it's still happening. So you get these benefits regardless of what API you're using.
So this is as of 2.0, this is all here?
Oh yeah.
Shipped. Done. Out there. Excellent. Well, 2.2 is the current, right? As of the recording?
2.2 is current. It was only released a few weeks ago, maybe 3.
That would be July of 2017 for those of you listening.
Any new features in that, or is it a bug fix release?
So, well, one of the coolest things in 2.2 is that structured streaming got moved into being a production-ready library. They basically took the experimental tags off of it.
Right.
Ooh, hot topic.
Yeah. So the reason that structured streaming is so exciting is all that stuff I just said about Catalyst, about all this optimization and these low-level operations, and this API that you can use in SQL, and you can use it in Scala, you can use it in Python, you can use it in R. Structured streaming does that for streaming. It says that whole API, that whole thing that you just learned to do all your batch stuff with, we're going to just make it so that you change like 2 things and now it's a streaming job instead.
That is really cool.
Yeah.
I mean, it's from streaming, let's face it, that's the hot topic right now with people working with data. Data at rest, great. Make it faster, make it easier for me to get to. But streaming data is a hard problem to solve. And there's I think there are a lot of projects, a lot of people talking about how to solve that problem. I think Spark can really get there faster based on their foundation. What do you think?
I mean, I agree. I think that one of the huge benefits is that in Spark, right, you can be working on all of your stuff. You can work on your code in batch mode. You can be testing out the same pipeline with batch code. And then all you do is you'll switch your source that you're reading from to a streaming source. And then the same code will work. So it should make the time to prototype and develop this sort of thing really, really quick for a lot of people.
So with Spark streaming, does that, sorry, I'm asking a lot of questions from asking for a friend. No, it's me. Discrete events versus micro batch, which is Spark streaming in the beginning. Micro batch was great for a lot of use cases, not good for discrete. So single object, what is there a change there? Now are we doing discrete as well as batch?
So that's the big dream. This is something that actually
I'm still dreaming.
Yeah. So Michael Armburst, one of the lead developers on Spark at Databricks, did a demo at Spark Summit this year. And of course, everyone dropped out of their seats when they saw this. But basically, he showed a per tuple based streaming using structured streaming.
Okay.
So
I'm not going to fall out of my seat, but I'm gonna if you keep talking.
We were all very excited. So while it's not in there yet, the way that the API is designed for this whole structured streaming is you can decide that maybe this is going to be better off using a per tuple. Maybe you really care about that individual item latency. You know, once an item goes in, you want to know about it as soon as possible. You don't want to micro batch at all. And he basically showed that it was possible to have this implemented inside of Spark with the way that the code is set up right now. So it does not currently exist. So if you're still looking for that, you'll have to go to something like a Flink or Apex or something like that. But it probably will not be too long before the code that you write for a micro batching environment in Spark Streaming could just be instantly switched over to a tuple-based event model. So,
wow. All right, so then I no longer have to add the Akka part in my Smack stack. Ooh. Uh-oh. We're going to be controversial here.
I mean, I don't know.
It'll be SMIC. Hey, all right,
that's a good I don't know.
He's shifting nervously.
Wow, you finally pinned him down. Ooh, you finally stumped Russ.
He's not stumped. No, he's just not wanting to say that.
I don't talk about people should or shouldn't use Akka. I'll leave that for you. You can talk about that.
Okay, it just got awkward, but I like awkward. Jeff saved us.
Speaking of awkward, I do want to comment just as a note here as we close. There has been a little bit of what I want to call it, maybe sticker shaming going on. We've gotten some listener feedback, some viewer feedback that noted the conspicuous lack of stickers on certain laptops compared to other laptops.
Sorry.
And we just want to say that we've noted this and we're taking it into account. You may notice if you're watching on YouTube that I've added a couple of things. I've got a new Spark sticker that I'm rocking on here right now with more to come. So look, the sticker space on my laptop is currently available. There's some real estate left. And
let's turn this into a thing.
If your tech is worthy, let's get it on here.
Yeah, so this should be a thing. So if you have a sticker that you feel like needs to be on Jeff's laptop, then let us know in the show notes or in the comments. You can hit us on Twitter at DataStax Academy. We want to. If you think it's worthy to be on Jeff's laptop, then
and it's an even
up.
trade. Like we got a lot of stickers here that we can share out the other direction. So
not my laptop.
Get this going.
My laptop is fine. I have my 26 pieces of flair. I'm good. But
plus,
yeah. So Russ, let's wrap this up with, I mean, let's just face it, the past of Spark, just you're catching us up on what's going on, looks really bright. I'm gonna have to revisit. But what's the future look like now that we've got all these goodies? Finish us up with the grand vision.
Yeah. Well, I mean, so the grand vision of Spark, right, is that you will have these machine learning libraries, you'll have graph libraries, you'll have all kinds of different technology that just fits on top of this Catalyst optimization engine. And you already see a bunch of it coming out. There's MLlib work, there's graph frames.
Right.
But these kinds of things are all going to take advantage of the same optimizer, the same thing. So people will be writing all kinds of different libraries, all building up this giant ecosystem that you can access without having to learn anything new. So it's all about this huge interoperability. I mean, we didn't even talk about how the fact that within Spark SQL, within this Catalyst, you can take sources from all kinds of different places like RDBMSs, NoSQL, file formats, S3. You can combine them all without having to actually write a new connector for any of them. And that's really what Spark is in the future.
I think we're going to have to get you back, Jeff. Take a note.
This may be a thing.
Yeah, I think we're just going to have it because we get behind and then we lose things. So, Russ, will you come back?
Yes, I'll come back.
Okay, so we got that marked in stone. He will come back. So I think the things we would love to talk about in the future are things like Spark streaming, graph frames, really some really low level things if you can demonstrate. Like, here's the code that I'm writing and look at what it's doing now. It would be great if we could show our viewers some of that.
Show some of the code gen that actually is happening under the hood.
Oh,
I like that.
So nerdy. Good stuff. Excellent.
Thanks, Russ. Well, thank you, our listening audience, for joining us for another episode, and we'll see you next week.
Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, make sure and subscribe so you don't miss a single episode.